today was the more sort of difficult calculus questions. So this is what we sometimes refer to as optimization or min-max problems. Different people call it different things. Okay, so this would be after we had answered the question on differentiation by first principles and our rules and our cubic function, we would then get a question on optimization. Sometimes it's about 10 marks. This particular year it was 7, that year it was 10, this year it was 8. So it's not a huge amount of marks, but if we're wanting to do really well, then obviously we need to be able to answer these sorts of questions. All right, so I've chosen some different ones for you, hopefully things that you haven't seen before as well. Okay, so the first question gives us a closed rectangular tank with a square base, and it has a volume of 300 cubic meters. They tell us that the length of the side of the base is X meters, and we can see that because they have labeled it for us, and they've told us that the height is H meters. So it's got a square base and it's H meters high. The first thing that they want us to do is they want us to determine H in terms of X. So in 10.1, we have to determine H in terms of X. So what are we going to sub into here, guys? Good, Linda. Okay, what about everybody else? You're going to sub into volume is length times breadth times height. Good, well done, Penga. You've also got the same answer. So you'd put in your 300, your X times your H. So if H is on its own, it would be, as both of you said, it would be 300 over X squared. Okay, so there would be a mark for subbing in, mark on your answer. All right, let's look at the next question. Now they've asked us to show that the total surface area of the prism is A of X equals 2X squared plus 1,200X to the minus 1. Should I maybe be quiet and let you guys try that on your own? Would that be better? Should I give you an opportunity rather than telling you what to do? Yes. Okay. Pinga says yes. Okay. So Pinga, I'll be quiet. You guys try question 10.2 and 10.3, and then I will reveal my answers as well, and we can mark it and discuss it. Okay, so I'm just going to start working slowly behind you guys. Hopefully I'm not going to put anybody off. Linda, I think that's correct. It's not an exact value. Okay, maybe they should have told us to round it off. Okay. Okay. Okay, so there's the solution for 10.2. I hope everybody was okay with that. Okay, so Chloe, Linda and Pinga, I know you guys have finished quite fast. Some of the others are just struggling a little bit, so just please be patient with us while I explain. Okay, so Kamogelo, Chloe, no problem. All right, so how do we calculate the surface area? Yes, Pinga, correct. How do we calculate the surface area of a rectangular prism? So the surface area is, remember, you've got your square at the top and your square at the bottom. And then you've got four faces around the outside that are all the same. So that's why I've said 2x squared, because that is the top and the bottom. And then you've got these panels on the side. So this one over here, which is x plus h, that one at the back, which is x plus h, this one at the back, that's x plus h. And then the one that's facing us would also be x plus h. So that's why it's 4x plus h. All right, so now area in terms of x is going to be 2x squared plus 4x. And now I'm going to take what h was, and I'm going to go and sub it in here. Okay, Kamogelo and Chloe. And then when I multiply, remember I'm multiplying numerator with numerator, denominator with denominator. So the 4x times the 300 is your 1200x. Your x squared is at the denominator. And when you divide like bases, you subtract your exponents. Okay, are you happy with that? All good. All right. Lovely. Okay. So that was 2 marks. So obviously we need to use the correct formula for surface area, and we need to go and sub that in correctly. We're not going to get any marks on the answer because the answer was given. And then in 10.3, we need to determine the value of x that will result in the maximum total surface area. So what I'm going to do is I'll just move that down a little bit because you're using your answer from 10.2, which you've got. So the rest of you can try that. I'm just going to go and fetch another question. Sorry. Pinga and Linda, I'm just going to move this up. And then you guys can start on question 10.1 while the others are still busy with 10.3. Okay. So don't be put off by Pinga and Linda, guys. Some of us just work much faster than the others. You concentrate on 10.3, and then they're going to carry on with 10.1 and 10.2. Yes, Pinga, I got the same answer. Correct. Good. Well done. Just going to move that up a little bit. All right. Are the rest of us ready to do 10.3? No, Linda, it's not wrong. That's correct. Well done. Okay, you and Pinga got the right answer there. I thought I'd keep you busy for a little while, but I didn't manage to keep you busy for too long. Okay, all right. So Linda and Pinga, just give me 1 minute. I'm just going to do 10.3 with the others, and then we can start on 10.2. Okay, all right, everybody. So for the maximum total surface area, remember when we maximize, our derivative has to be equal to 0. Also, they said the word hence. So the word hence means we've got to use what we previously calculated. All right, so in 10.3, we have to take the derivative. So that would give us 4x minus 1200 x to the power of -2. So we've got to take our derivative. We've got to make it equal to 0. And I'm going to put that over x squared. And then what I'm going to do is I'm actually going to take this whole term over to the left-hand side. So I've got 1200 over x squared is equal to 4x, and that's 4x over 1. And now, guys, I'm going to cross multiply. Okay, so that is going to give me 4x cubed on the left, and it's going to give me 1,200 on the right. Okay, I'm going to divide both sides by 4. And now I need to take the square root, sorry, the cube root, I beg your pardon, of 300. Okay, so when you round that off, you should get 6,69. Okay, are there any questions about that? 10.3. Any questions about 10.3, or the rest of us all happy? So we've got to take the derivative, we've got to make it equal to 0, and then we've got to solve for x. Okay, so since no one's saying anything, you got the same. Well done, Letu. That's lovely, brilliant, well done. Voloshin, do you want to ask a question? Voloshin, you're welcome to ask, and then Lesedi, I'll answer your question.
You can unmute Volation on your side, unless if it was a mistake. It was a mistake. Okay.
Oh, it was a
Sorry
mistake.
about
Okay, all right. Lesedi, they can ask you a question that is based off of a minimum as well. Under these conditions, it would have actually, would it have given you the same answer? So there's certain situations where you would then have to go and look at your cubic function in order to decide which x value you would use. If your graph was concave down and then concave up, your smaller x value is going to give you your maximum, and your larger x value would give you your minimum. If your graph was that shape, then your smaller x value is your minimum and your larger x value would be your maximum. Okay, so you're equating the derivative to 0 because the gradient at the turning point is 0. That's why you're doing that. Okay, so but at your maximum or your minimum, the gradient is 0. All right, that's why you're doing that. Okay. All right, not a problem. So Linda and Pinga tried question 10.1. I would imagine they probably want to go on to question 10.2. So I'm going to let you guys start that. Linda and Penga, you try 10.2, and the rest of us are going to have a look at 10.1 in the meantime. Okay, so they've given us f of x, and they've told us it's equal to 3x minus 2 squared, and f prime p is equal to 6. They want us to determine the values of P and Q if the tangent meets F at the point P and Q. So P represents the X coordinate at the point of tangency. Q represents the Y coordinate at the point of tangency. I think what I'll do is let me give you an opportunity to try it. And if you get stuck or you're not sure, then I can, well, I mean, I will do my solution anyway, but then I can do a solution. You guys try that question 10.1. Okay, Lyndon Pinker, you're on 10.2 already. And don't worry, I've got another question for you guys to do after this as well. Okay. Yeah, we're going to do that this whole lesson. Okay, Tsechofatso. Linda, give me a second. Let's see if we can fit that one in as well. Sorry, I was just doing that. Good, Sihawu, that's right. Okay, Linda, I'm going to get back to you right now. Yeah, Linda, I'm getting the same answer as you for 10.2.1. Okay, so Letu, I got a different answer to you for 10.2.1. I won't say what I got, but my answer was different. Okay, but I will go through these as well with you guys. Just give me a second for 10.2.2, Linda. Yeah, Linda, I'm getting exactly the same answer. Correct. For 10.2.2. Oh, okay. No, see how we got different answers for Q compared to you. Ah, that's interesting. Yeah, Pinge, I think that might be what you have done because your answer is the same as Letu. So remember they wanted the speed. Okay, not the meters. Okay, it was the speed of the object at 4 seconds. Okay, but your answer for question 10.2.2, Pinge, is perfect. Okay. All right, have I given the rest of you sufficient time to think about 10.1? I know that Letu sent me some answers, but I haven't heard anything from the rest of you. How's it going with 10.1? Are you managing? That's not what I got, Pinga, but I'll show you how I did it. Yes, Lesedi. Oh, good. You guys are doing it. Yes, excellent. Well done. Linda, let's see if we can get you another question on the board. Voloshin, is that for question 10.1? Cool. Yes, good. Well done. All right. So now you're ready to start 10.2. Good job. All right, Linda, let's get you another question. Okay. All right. Let's see if we can move this up. Okay. So Linda, I'm just going to have to make this a little bit smaller because there are still people that are busy. Okay. I don't know where I'm going to put this, Linda. Are these still like easily visible even if I make them a bit smaller? Okay, there you go, Linda. You can start on question 9.
Yes, we can still see it.
You can see it. Oh, you took a pic. Oh, okay. All right, that's cool. Oh, lovely, Boycho. Well done. Very nice. Okay, Trish, I didn't get those answers, so we're going to have to just go through that. Yes, Lesedi, good. Okay, so Letu, that's one of the answers. You should also have a second answer in 10.2.2. There should be 2 answers. Okay, I think what you've done there, Boycho, is you've worked out the distance. I got a different answer for speed. Okay, so what I'm going to do is I'm just going to start slowly behind you guys, and I'll put up the solution for 10.1. Okay, so that's how you would have worked out the value of P. And that's how you would have worked out the value of Q. So hopefully everyone's all right with 10. That's it, Kamachelo. Good. All right, well done. Very nice. Okay, so Kamachelo and other people, you're ready to do 10.2. And then I'll put up those answers as well. The next one is also a speed distance time one, because those are generally quite tricky. I know it's crazy. Hey, Tsechofatso. Like 5 days. Hey. And then you start. It is unbelievable. Yes, Linda. Yeah, those are all correct. Quite right. Perfect. Well done. Pingo, you trying question 9? Okay, so Bali, that's not what I got. Oh, yes, Pingo, I can. Okay, okay, so Tsechofatso, if you have a look, the solution for 10.1 is there on the board in the pink. So you have squared your binomial and you've got f of x. Then they've told you that the derivative, when point P is subbed in, is 6. So we've taken our first derivative, we've subbed in our 6 for our gradient, and we've subbed in our P because that is the x coordinate at that point, and then we've solved for P. Okay, and then to get your Q value, you're going to sub your 1 back into your original. Okay, and then you got 1 as well. Okay, I don't know if I've missed anything that anyone has said. Ma'am, please can you explain 10.1? Done that. Kamogelo, writing IT. All right, I hope that you can see that a bit better now. Pinga.
Yes, it is clear.
Okay, so 10.2.1, no, that's not what I got here. I'm going to do the solution for that now. All right, so in question 10.2.1, Okay, Linda, I'll get back to you now. I'm just going to explain this to everybody. Okay. If they give us distance, distance is s of t. So speed is the first derivative. And acceleration, not that they ask us about that, would be your second derivative. So when they're asking you to determine the speed of the object at 4 seconds, they want you to take the first derivative. So that would be 3t squared minus 4t plus 1. Yes, rate of change is the same, well, rate of change is, so it's not necessarily acceleration though, Linda, because when they talk about rate of change, it can either be speed or it can be acceleration. So when we're talking about speed, we're talking about how distance is changing with respect to time. When we're talking about acceleration, we're talking about how speed is changing with respect to time. That's why acceleration would be the second derivative. Okay, so velocity, this is distance. So S of t is distance. So that means S prime t is speed, the first derivative. And the second derivative is going to be acceleration. Okay, because remember, our derivative tells us how our change is
I think
taking
there's something
place.
wrong with the network.
Oh, okay.
No, on my side, she's okay.
All right. So in 10.2.1, we are going to sub 4 into the first derivative. Okay, and then you should get a speed of 33 meters per second. Okay, so there would be a mark here for the first derivative, a mark for subbing in the 4, and then a mark on the answer. Is everybody happy with that? All right. And then did you manage to calculate the values of t for which the speed will be a minimum? So that would mean making your first derivative equal to 0. So you'd have 0 equals 3t squared minus 4t plus 1. And then you would have to factorize. And both would be pluses, and that would be, sorry, both would be negatives. What am I talking about? Sorry. And t would be equal to 1 over 3, or t would be equal to 1. Okay. No, Tsechofatso, you don't. They won't mark you down, but I'm just in the habit of always putting in my units. All right. Is everybody happy with question 10.2? Okay, so equal to 0. Okay, I'm going to take that as a yes. All right. Then we're going to do question 9. So I know some of us have already done question 9. Let me just move this down a little bit more so that we've got space to write. And then I just want to bring this question up. So Linda, I don't know if you've seen this one before. Okay, and then hopefully that is big enough. Wah! Okay, so I suppose we don't need it to say question 9. That's really not important. And then let's just make this a bit smaller. Unless maybe, Linda, you should just take a picture of it. Just take a picture of the question you did. Okay, cool. All right, Pinga. So Pinga, you also take a picture of question 11, and then you can work on that together with Linda, and then we can let everybody else work on question 9. Yeah, that one is confusing. Okay, but don't worry, Pinga, we're going to go through it now. I just want to give everyone a chance. Okay, hopefully Pinga and Linda have got their pictures. All right, everybody else, we're going to do question number 9. Okay, so again, I'm going to give you an opportunity to work on this. Please reach out to Yolanda and I if you don't understand. Tegofatso, what did you want to ask me about 10.2.2? Oh, you want to take a screenshot of the answer. Okay, all right. Sorry, everybody, just give us 1 second. Go for it. There you go. Screenshot that quickly. Tegofatso. No problem. There we go, everybody. How are you doing, Matrix? Is everyone all right? Okay, Swanaka, that's fine. Maybe it's one of those sorts of questions that it's so easy that it's actually difficult. All right. So the car's height in meters above sea level after t minutes is your expression for S of t. All right. So at the beginning, when they begin their journey, what is t equal to? At the very, very beginning, when they begin their journey, t would be equal to 0, wouldn't it? Okay, so what would happen if you subbed 0 into your expression? Exactly, Lihlu, t is equal to 0 at the beginning of the journey. So what happens if we subbed 0 in? Swanaka, what would happen if we subbed 0 in? So we subbed an S of 0. That's it, quite right, it is Lihlu. Okay, so you'd end up with 5 times 0 cubed minus 65 times 0 squared plus 200 times 0 plus 100. Okay, so all of these terms would become 0, so it would be equal to 100. Okay, so the car is 100 meters up. That's it, quite right. Yes, Letu, correct. Good, well done. Right answer. Now you can go on to 9.3. That's correct, Linda. It's tricky, eh? It's a nice question, isn't it? But that's the correct answer. Well done. Yep. So that'll be the hardest question, or one of the hardest questions in paper 1. Good, well done. Boyd Show. That is not what I got for 9.2. My guess is, hopefully you read the question carefully, Boycho. Okay, remember, calculate the rate at which the height of the car was changing. Okay, so the rate at which the height of the car was changing, what are they referring to here? Mosey, is that your answer for question 9.2? Okay, so the rate at which the height of the car was changing. So Mosey, your second answer is correct. It's just your sign that's wrong. Okay, is not acceleration. It's going to be your first derivative because it's the rate at which the height of the car was changing. All right, so it's the same. No, Sihawa, I didn't. Okay, so for question 9.2, the rate at which the height of the car was changing refers to the first derivative. So in question 9.2, I worked with the first derivative and I got 15t squared minus 130t plus 200. So at exactly 4 minutes into the journey means you need to sub 4 into the derivative. So when you sub in 4, you'd end up with an answer of negative 80. Okay, so that means what exactly? The car is now driving downhill. Okay. So that's what we should have got for 9.2. Okay, so if it's a negative answer, it means the height is not increasing, the height is decreasing. So the car would need to be driving downhill. Does that make sense to everybody for 9.2? Voloshin, go for it.
Ma'am, I'm having a problem understanding. Is it that when it comes to the acceleration and velocity questions, how do you know if it's the first or the second derivative?
Okay, all right. So, Voloshin, that's a very good question. Your first derivative tells you how whatever your function statement has been given, it tells you how that is changing with respect to time. So, for example, if s of t is distance, your first derivative of distance is speed, because speed tells us how distance is changing with respect to time. Okay? Your second derivative tells you how your first derivative is changing with respect to time. So acceleration is the change in speed with respect to time.
Okay.
Does that make sense to you now?
A
So
lot of sense, yeah.
okay, so in this particular question, we're talking about the height of the car. So S of t is the height of the car. So when they talk about the rate at which the height of the car is changing, they're talking about the first derivative, absolutely. And then in the second, in question 9.3 now, after how many minutes into the journey will the rate of the change of height with respect to time be a minimum? So now they're talking about how the rate of change is changing. Okay, it needs to be at a minimum. So in question 9.3, they are implying that you would use the second derivative. Does that make more sense now?
A lot of sense, ma'am. Thank you.
Okay, no problem. All right, Pinga, no stress. That is off a past paper, so you will be able to go and have a look. I don't know if I'm going to have a chance to do the solution to that just yet before the end of the lesson, but let's see what we can do. All right, so question 9.3 refers to, and I hope the rest of you understood what I was saying to Voloshin. They're talking about the rate of change of height with respect to time is a minimum. All right, so they are implying that we need to use the second derivative. So we would derive the first derivative, that would give us 30t minus 130, and when it is going to be a minimum, that would be equal to 0. Okay, so if 130 is equal to 30t, we would divide both sides by 30, and t would be equal to 4,33 seconds. Okay. All right. So, Tsehufatso, I was talking about how you would know whether it was the first derivative or the second derivative. Okay, so when they talk about the height of the car is S of t. So in this case, S of t is the height of the car. So S prime t is going to be the rate at which the height of the car is changing. So rate at which height of car changes. And then our second derivative, they are asking us how many minutes into the journey will the rate of change of height with respect to time be a minimum? Okay, so now we are trying to minimize the rate of change. So that's why it has to be the second derivative. We're trying to minimize the rate of change. Okay, I hope that's coming through for all of you and that this is making sense. You're a little bit quiet. Does that make sense to you why it would be the second derivative? So we are minimizing the rate of okay, so that's coming through. Okay, cool. All right. And then what I had done, I know that Yolanda popped the poll onto the screen. What I had done as well is...
Sorry, Teacher Leah.
It's okay. No, that's fine. So, I'm sorry. I'm just trying to answer Tsegofatsu's question. So speed can be asked for both. What do you mean by that, Tsegofatsu? I don't understand. So if you've got distance and time, speed is your first derivative. So the rest of you, this was the last question that I put on the screen. This comes from the 2021 final paper. Okay, so so the rest of you can take a screenshot of this and give this question a try. Pinga, what I will do is on Thursday, I will put up my solution for this. Okay, so this is a particularly difficult question. I'll give you a hint, Pinga and everybody else. So you are going to be minimizing cost. So you want to develop an expression for cost in terms of X. So Pinga, your cost, the cost to this person consists of two things that you're going to have to add together. So I'll give you a little hint like that and let's see where you end up with that question next time. Okay, Pinga? Right. So Tsegofatsu, I'll say what I was saying earlier again. All right. So if your expression is for distance, then when we're talking about the first derivative, okay, the first derivative will be speed because that explains how distance is changing with respect to time. Okay, your second derivative explains how your first derivative is changing. So that's why with speed, distance, time, acceleration is the second derivative, because acceleration explains how speed is changing with respect to time. Okay, shame, Pinga. Yeah, this is definitely a tough question. So yeah, write an expression for cost in terms of X, and then that's what you would have to minimize. All right. I don't know. I don't know how we are on time. I can do it for you if you want, or maybe give you guys an opportunity to rather try